Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So I hope everyone is in good state, good health and also good spirits. So I am Dr. Siti Norafida binti Yusof and this is environmental geotechnics. So for today, our topic is contaminant transport. So as you could see in the figures in this slide, okay. So we know that there's very complex and difficult condition in order to predict the movement of contaminants. So we could see that contaminants can comes from the agriculture, okay, such as fertilization and also erosion of the soil. Of course, also come from industrial, okay, and also from the municipal or urban usage. So there is a lot of process or activity occurred during the I think contaminant transport. And of course, different types of contaminant will react differently with either with soil sediments or water, and it is commonly travel along a different flow path and also at different velocity. So it is quite challenge actually for us, the geotechnical engineering and of course hydrogeologists, to obtain the meaningful chemical data, especially the contaminant that we observe from the observation wells or monitoring wells, to help us to map the distribution of the contaminant. And this is very important for us because we want also to estimate or to target for any models that we can build or we can construct to predict or to predict forward or predict backward in time to understand how the contaminant occurs and how far the contaminants can go. So that is the aim of our course, our this topic lah. Okay. So what is contaminant? I already asked for in the last session, and I see some of you have give very good answers. So let's see what is contaminants. So of course, contaminants is something that we don't want because of the impurity uh, of the things of the pollutants that will might spoil or corrupts or infects or makes unfit of especially our ground and water and so on. So in this subject, we'll more focus on soil contaminants. So of course, it relates to the land degradations. This is due to the human-made chemical or other alteration in the natural soil environment. And as I said just now, it can caused by industrial activity, agricultural chemicals, and also due to the improper disposal of waste. And contamination is things that we don't want, okay? But it is closely correlate with the degree of industrialization and also the intensity of the chemical substance. As we could see previous in the first topic, the Love Canal incidents, right? So there's a lot of chemical substance has been dumped in the canal, about more than 20,000 tons. So of course, the land has been degraded. Okay, not only the land is degraded, but we also concerned about health risk, either when we directly contact with the ground, or due to the vapors that release, or due to the water that we use as a supplies, and of course the underground water that will affect our agriculture. Okay, this is just figures on how the mechanical of metal absorb in the soil particle. So it will affect the soil state and of course affect our health as a human that interact with the soil. Okay, before we go further, okay, let's see how we address the contaminant concentration in soil. So we know that soil have solid particles, we have water and air. So these three components will lead to the concentration total of the contaminants in the soil, in the unit volume of soil. So if the soil is saturated, so only two component left. We don't have any water, any air. So we only have a solids and also the water. So I hope you still remember N is for porosity, rho bulk is for soil density, and so on. Okay, another things that I would like to introduce, you will see a lot of this term, NaPl, actually, non-aqueous phase liquid. Okay, so this is the popular contaminants that will sink into our ground. So we can have a dense non-aqueous phase liquid or light non-aqueous phase liquid. So this is typical density of NaPls for the dense and also for the light one. So you can see pollen, benzene, diesel fuel, and so on. At this side, we can see PCE, TCE, coal tar, and so on. So the denser the NaPl can be, so in theory, the further the contaminant can transport in the ground and in the water. So this is another I think representation of how the contaminant will flow in the ground. As we can see, this is unsaturated zone. So in unsaturated zone, for the light NaPl, it could have a migration and surpass the water table and goes further away following the groundwater flow direction. The NaPl can also change its state from the liquid to vapor. So vapor plump of volatile NaPl can also take a lot of area. So next, this is another representation of the how far and what the activity of the contaminants can involve with. So they can change their state. At first, it is a chlorinated solvent, and the storage tank is spill the contaminant, so it can dissolve into the soil. It can volatile and becomes a vapor also. And once it surpasses the water table, it might be a dense NaPl. So it could disperse and dilute more in the ground, and it can create plump and so on. So this is another representation of how far the dense NaPl can go in unsaturated and saturated media. Of course, in saturated they can go more further. And this is another representation. If we could see the differences of K, hydraulic conductivity in soil. Okay, the denser it goes, the high K. So the higher the hydraulic conductivity, so the more further of the contaminants can go. So another figures. So this is a lot of vapor in here. As a solvent, vapor is denser than air, so it will sink later to unsaturated zone and might contaminate the groundwater. And this is the dense NaPl. Okay, so it moves quite slow. Okay, because then dense NaPl must displace the water rather than the air. But it continues to move until they create a pool. Okay? And here we could see the light non-aqueous phase liquid pollutants floats on the water saturated zone of capillary fringe. Okay, This is what groundwater table, but they have a unsaturated zone of capillary fringe, negative for water pressure in here. So how they float around here. Okay, by knowing the contaminants can move further and deeper inside our ground, so it is our job to identify how much the contaminant concentration is spilled in our ground, soil, and at least we can predict where the contaminants can flow and where it's go. Okay. And later, once we finish this topic, contaminant transport and feed, we will learn how to do site assessment and also how to do the remediation process. Okay, so how the contaminant seep, migrate and sink into soil? Of course, by having transport and feed and also transformation or degradation. Okay, in this course, we only cover the transport and feed. So for this one, we will not cover in our courses. And for the transport, so this is topic, we'll cover in the topic 3. So we have advection, diffusion and dispersion. So I hope you already also read the journal that I give you, Lycos journal. And we will use the journal as our reference. Okay, okay, for advection, as we could see in the Lycos journal, so the analogy is like we have a chemical in the water, but we stir the water, but the water have a sharp concentration in front. So that is the advection. It refers to the contaminant movement by flowing the water in response to a hydraulic gradient. And to calculate, we have to know the groundwater velocity at least u, or sometimes in this slide it also represent as v sub s, u or v sub s. And advective flux is how we want to define the mass flux through a unit cross section due to the groundwater advection. So in this study, okay, we have advective, diffusion and dispersion. So this is number 1. So J, advective flux, J sub A equal to porosity times the flow velocity, U equal to K times I, and also the concentration. Okay, so one example of the advection situation. Okay, let's see. A landfill site have a dissolved chloride with a concentration of 1000 milligram per liter C. Okay, and it has been transported, means there is polluted contaminant in the site, and has been transported along the leachate through a 1.5 meter thick natural silty sand into a underlying aquifer. So the flow velocity is u equal to 0.03 meter per day, and n is 0.1. So what is the mass flux for the chloride? Due to the advection alone, only the advection. So just a simple solution. So it is 1000 times 0.03 times 0.1. So we get the answer 3 gram per day per meter. So this is the mass flux for this advection activity. Okay, I think I'll stop here. So later we see how the diffusive flux is calculated. Okay, so that's all until now. Assalamualaikum and see you again.